Okay, I don't know what happened to the volume of that one, of the last demo. So I'm going to take this out for you, and then I'm going to re-upload this, and let me show you what you got to do. Also, I know the machine learning one is kind of, at least on my machine, was crackly. I use a recurrent neural network to kind of normalize my voice. I have a very deep voice, so I don't know if it's just the model collapsed or what happened. So again, I apologize for that. I'm gonna give you guys an extra week. It's not a hard assignment. It's a 15-minute assignment, but I don't want you guys to focus on deadline. I'd rather have you guys focus on learning and doing a little bit more research on this. So let me get the linear regression. But basically, for this assignment, it's relatively easy. I can explain it to you here in 30 seconds. I have some code which I'll demonstrate here, probably in what 15 minutes, and I get a score. I think like an R score of 0.36, 0.4, something like that. All you have to do is get a better linear regression score. Now, oh my God, that could be really hard. Well, yeah, it could be, but I also include demos of how to get better scores. So you can use some of the demos I use, some of the tricks I use. You can increase the accuracy in multiple different ways, or if you're less interested in actually getting a better score and you'd rather make a more visually appealing graph, you can do that also. Okay? Or you can make a price prediction. And I think I go through all three of these demos. Because let's think about this as a professor, or as your friend, or as a coworker, or as your boss. If I teach you something, that's great. But you're likely to forget it in 8 months, 8 weeks, something. So if I can show you how to do something, you do it, then you Google and add on to it and build a foundation. I think that is really the best way, because once you build onto the foundation, I hopefully have laid for you, then you can go back in 6 weeks or 6 years or next year, and be like, hey, I did this, I did that, and I remember changing and Googling this. So that's why I don't try to teach a super heavy didactic. Here's a math formula for linear regression, because I don't think that a lot of the math really translates for long-term education retention. I'd rather have you do it, build onto what you do, and revise and Google and learn, and that way something really sticks with you. Maybe we learn how to change a flat tire in driver's ed. But trust me, once you have to change a flat tire in real life, it's a much quicker learning process. You figure out these jacks are like not very stable, and there's like traffic around you, and it's very nerve-wracking. But that's one of the better ways to learn. So let me pull up some code. I'm gonna show you a little demo. I literally Googled simple Lightroom, or sorry, not Lightroom, simple linear regression. I don't know, data set, and I downloaded it. It's got like 20 rows in it. And then I just did a real simple linear regression notebook to go into a little bit more details of linear regression. And then that's this right here. That's salary data set right here. And sample data, it's salary data set. Ooh, can't speak today. So this just gives you a kind of overview of linear regression in real code. And this is the homework. And like I said, there's plenty of examples in here. It should be super easy. But I would really appreciate if you guys kind of took this and said, oh, hey, what does this do? Hey, what does that do? Use ChatGPT, use Claudia, use Google, use Slack Overflow. There's a lot of resources, and try to figure out, hey, if I use ridge regression, how does that help me? What should I watch out for? If I get rid of outliers, what impact is that going to have on linear regression? So let me load up the notebook here. Okay, convert. I don't know what Excel is saying. Okay, so here is view 200%. Okay, so remember, what is the general goal of linear regression? So we don't really need this column, so let me just get rid of that. Okay, so we have years of experience and salary. Dude, this is like what? Yeah, 30 rows. Super simple data set. So what we're saying is, hey, if you have 2 years of experience, you get 43,000. You have 4 years of experience, you get 63,000. You have 5, you get 67. But let's say I'm the CEO and I'm making billions of dollars. I want to know, hey, what does somebody with 15 years experience have? What about 18 years? What if we develop some great drug and somebody can live to 80, 180 years, and this guy has 80 years of experience? In theory, what would his salary be? So that is the general big picture idea of linear regression, is to predict this from never seeing these. Okay, I think that's right. That makes sense. So we're trying to predict a variable from this. We're trying to predict 12.8 from this. Okay. So again, it's a super simple 30-row data set. A simple linear regression. So let's load. And this one I just did locally. I'm sure it will probably work on. Actually, let me load it up on Colabs. Actually, here, I'll just load it up here. Actually, I want to be consistent, so let me load it up on Colabs. Okay, so I'm just going to go File, Open. Drag this notebook in here. Nope, this one. So again, this is it's called Simple Linear Regression Salary Database. Okay, so let's do my imports. I'm using pandas and NumPy. Let me upload my data really quick. Sample data set. Let's drag it on here. Yes, we know. Copy path. And let me just put it in here. V run. Booyakasha. So we have that. Okay, sorry about that. There we go. So, yep, loaded right here. Salary data set 8. Again, just like we saw, 2 years, 43K, 4 years, 63K, and it terminates around about line 30. So we have no nulls. That's good. Just some standard real low-hanging descriptive stats. Mean is 5.4 years. Average salary is 76,000. The max, the minimum, and an extra dead cell. So let's just delete that. There we go. Assigning basically X and Y. Just run that right there. We're just using scikit-learn, which is already part of. I could have included this in the very top part of my includes with pandas and NumPy, but we're just going to include right here. And we're just going to split the test train. The reason we do this is because we want to make predictions. We have to kind of train the model. This is basic machine learning. So we have to, train the machine, and then we have to test what we train. Let's do that. Really important factors here are test size, O2. So that means I'm going to train on 80% of the data, and I'm going to test on 2%, 20% of the data. I'm trying to do the math in my head. And then random state is just where it kind of starts. I always use 103. October 3rd is my birthday. You can use any date you want. Normally, a lot of computers use 42, so it's whatever you want. We're just going to import linear regression. Boom. And this just basically does your prediction. And then now, so R squared, our theoretical accuracy is 99.3. Okay, so now there's a million different ways, maybe not a million, probably like 5 different ways, I don't know, to really determine how well a linear regression model fits a given problem. Okay, so R squared is it's low-hanging fruit, it's very common, and basically the way you can think of R squared is how well does our model predict using the variables we have. So it is like how much of the variance of the dependent model or the dependent variable can be explained by the independent variables. How much does one column explain the other column. So this becomes more important when you have multiple columns. If you have 3 or 4 columns of data trying to predict one column of data, R-squared becomes more important. If you have larger data sets, it becomes more important. On here, we have 30 rows. I mean, we could literally just look at this and say, hey, we can kind of guesstimate where the linear regression is going to be. Okay. So, guess maybe I should Google this. I just thought about it. So I know there's an adjusted R squared. Oh, what else is there? There is root mean squared sum, root mean squared error, root mean squared error. No, it should be lowercase. There's absolute. I think it's just a mean MA, which is mean absolute error. There's AOC. There's F and T. So it'd be and honestly, the T statistic, I've only used that in class years ago. I'm sure people use it. And then F score, F statistic, TSC. Oh, what else is there? There's a couple other ways that you can look at it too. Oh, you know what? Area under curve. Oh, ASC. Or it's not. That's another method for Bayesian statistics. Those are the ones I can kind of think of for linear regression. Okay, let's keep going. So let's just kind of look at what we have here. So this is what we have. So if you go into Excel and you could grab that little spreadsheet of 30 points and plot it, and kind of here we go. So we know we have really no values beyond 10 years. We have no values really above 120,000, 120K. So this is what our data looks like. So this, like I said, this is what makes it so nice. We could literally just take a ruler and go from here to here and plot. And that's one of the reasons I kind of wanted this data set, because it's so simple, so clean. I mean, 30 rows. So yeah, just draw lines. Right, there's a linear regression line right there in the middle. Let's see, I think I did that. I think I put a line right in the middle. Oh, look at that. There's my regressor. Okay, so that kind of tells me that if I had, let's say I didn't have these numbers and I wanted 6 years, I could kind of estimate, hey, 6 years is right about 80, 82-ish. You know, I'm not that good at tracking with my mouse, but it would be right about there. You could figure out 8 years. Let me go up here. 8 years would be like 94,000 maybe. Okay, so there we go. Okay, so now let's talk a little bit about linear regression. I know I put the plot in here somewhere. Y equals mx plus b. So just in a nutshell, mx is the effect of that variable. X is the effect of that variable. Actually, let me see. Maybe I'll just Google it real quick. But m is basically that variable. X is the effect of that variable, and b is the error of that variable, the residuals, what they call. That's how you can kind of think about it. Okay, so m would be like the salary, and if you had multiple ones, this would be the effect of the salary. So you know, when I learn linear regression, the way I always think about is that housing data set we always talk about. So you have 4 bedrooms, you have 3 bathrooms, you have a big backyard, you have 3-car garage, 2-car garage. So each one of those variables, bathrooms, bedrooms, maybe the number of garages, those would each be your kind of m's. X is how important it is, in my mind, to your buyer, but it's really to Y. So maybe the number of bedrooms has a very direct effect on the price. That's X. Maybe the number of garage doors has an effect, but not really super significant. Because you don't want like a big mansion, you don't want like a Jeffrey Epstein mansion with 2-car garage doors. I mean, you got Ferraris and Lambos, and you have 2-car garage. That would be really bad. So, you know, M is literally the variable that helps predict the price of the mansion. So number of bedrooms, number of bathrooms, number of garage doors. X is the weight of that effect, and B is just a residual error. Okay. So that's really the easiest explanation I can give it to you. So now if we look here at the regressor or the regression line, I always call it the regressor or the vector, we can see that this plot or this dot, this observed, is 7,211 away from our prediction. This one is and I'm not going to worry about negatives because normally you work in absolute values, but this one is negative 4,159 away from our regressor, from our line. This one's 7,000. This one's 7,000. So basically, what the machine tries to do is make the best line to minimize each one of these errors. And, you know, it's nice that you can actually see it on a plot. And you can change it up here. I think I just picked, what, 1, 2, 3, 4, 5. Somewhere up here, there's 5. But basically, this grabs the 5 million numbers and basically just plots the actual value versus the predicted value. So I want you to see this in real life so you can understand how regression works. So now you know. You have the actual value, you have the predicted value, and then you have the difference. Easy peasy. Okay. So now, this is what I was talking about right here. So I made like a little notebook here. So if you have 15 years of experience, boom, it says you should be making 167,000. So let me grab my Excel notebook here, or my Excel data. I don't have it up right here. Okay, so I said with 15 years, you should be making 167 and some change. If I run it for 12 years, 138 and some change. 12 years, 130, we'll say 139, we'll round up. And then 20 years, 214, 215. 215. Well, you know, just looking at this, just using my eyes, using common sense and estimating, that looks about right, you know. 5 years to 10 years, we go from, I don't know, 60 to 120. So that's kind of double. Then from, you know, I mean, not quite, but, you know, then from 10 to 20, we go to 215. That seems about right. You know, we go from 8 to 10, which is 8 is 100. 10 is, let's say, 120. And we go from 10 to 12, we go to about 139, 140. That seems about right. So this is kind of right. And this is the whole goal of linear regression right here. It's not, I mean, it's not really all this math. It's not all these formulas. It's not, I mean, maybe cleaning outliers. But really, I mean, here is where it is. Because again, if we can predict the salary on something simple like this, what else can we do? Maybe we can predict the price of stocks. Maybe we can predict the price of a house. Maybe we can find something that's undervalued. You know, we can look at that car Craigslist data set. We can look at cars and say, here's the linear regression of mileage, and here's all the cars. So we take all the mileage and we take a particular type of car, and we look at it and we say, hey, here are cars that for some reason are under our expected value. We predict a car with 100,000. We predict a 2015 Tesla with 100,000 miles to be $80,000. Well, here's a car that's $60,000. So it's under our predicted value. All the variables are the same. It's a good buy. Here's a Tesla with 100,000 miles in 2015, and it is 110K. We know it's above our predicted value. I mean, if you're going to make money, wouldn't you rather make $7,000 profit than lose $7,000 profit? So, and salary, you'd rather be up here than under here. Okay, so what else did I have here? Here's the actual linear regression formula. Again, you guys take this notebook, save it on Google Drive, or save it somewhere and use it later. What else? Okay. Actually, I put the regressor in here just so you have it. You know, I've taken classes where they make you write out the formula and you have multiple regressions, and it didn't really help me. I've never been in business, and no business leader ever won the actual regression formula. They always wanted the result. They want to know, hey, if we open a business here, what are we going to make in 3 years from now? If we do this, what are we going to make in 2 years from now? So, where's that? So let's actually get into the homework. Shall we? Open notebook. Oh, upload. Okay. Well, you know what? It's not going to work because I changed my password after my last video. Give me 1 second to grab the new password. Since I display my passwords here, every time I do a video, I have to change my password. So let's just verify that I changed my password. Yeah, I know it's not going to work. Okay, and like I said, I've always warned you, when you post things to GitHub or when you post things to anywhere in the world, always make sure to remove your passwords, change your passwords before you post it. Like, I'm going to change this password right here before I upload it. I mean, I know there's only like 30 some people in the class, 28, 25, but still, you never know. Also, same thing with API keys. Always remove them, always change them. So let's just type in the wrong password. I'll be right back. I thought I had the right password. Okay, so let's see. I gave up on trying to remember the password, so I just reset it. We use a real simple password. So what we're doing right now is we're just going to grab that cars Craigslist data set we've been working with. A lot of you seem to like that. I want to find vehicles where the price is not null, where the year, they have to have a year. And then just kind of dive in a little bit more. The price has to be between 1,000 and 60,000, and the year has to be between 2000 and 2020. I think originally when I did this, it was a little bit more open. So we're just going to save that here. Okay. We're going to shift that to the data. And I try to make a little bit better note. So X is a year, Y is a price. Again, we do the split like I told you before. And even adjusting the split, that will increase or decrease the R values. You just play with one variable and get different results. Okay. We're going to train it, make a prediction, and we're going to print out the R squared. Make a little graph. Yeah, so I think originally when I did this, it was 1990. Maybe it brought up to 90K. Yeah, so yeah, 35.3. So I was somewhere about in that area. So this is your goal, to beat that. To literally beat, and that's a pretty poor predictor. Okay. So at 35%, it's basically saying that the price only the price has only kind of predicts the year. These are only related about 35, 36%. Actually. So you saw by just cleaning up my data a little bit, let's say 2,500. There's still a lot of bad data out there. So let's go in 50K between 2010 and 20, there we go. And if I just include Toyota, which is really a lot of bad data, look, I'm already at 37%. Not a huge difference, but I mean, it's a difference. Get rid of some more bad data. So what else can we do? Well, I think I included some residual plots, so I turned them off. QQ plots. So in the main linear regression, I talked about residual plots. Here's what an actual residual plot looks like. Remember, what's residual? Residual is your error. Okay. histogram of residuals. Kind of disheartening. We have a little chunk over here. This should be a little tighter. But so that's what that means. So I probably can figure out a way to change my SQL statement, maybe tighten it up a little bit more, and get a little bit better normal distribution. And once I get better normal distribution, my my predictor will be better. My R squared will be better. There's a QQ plot. So a QQ plot you want kind of on this line. Examples of bad. What you're trying to avoid is things that look kind of like a curve of bad QQ plots. Like, see how that's kind of like these. Oh, there we go. So, if it's a little wompy, don't worry about it. But this, when you start getting these weird, like this, those are where you have problems. So, okay, well, I'll have to update all my passwords here. So in this one, I'm trying linear regression versus ridge regression versus lasso regression and polynomial regression. Polynomial is probably going to be better because, again, it works better a little bit for time series. We don't need to plot all these. Actually, I think I put a right down here. So between increasing the SQL select, making a little better SQL select, and using different types of regression, you can see that I've been able to increase my R squared to 54. Even polynomial is 57. So you literally could do something like this. Go back up here. And you'd be basically, the assignment's done. Okay? But again, I want you to kind of experiment and play with this. Here's some different types of regressors or regression. We did what we did before. We also include support vector regression, random forest, XGBoost. So it's a couple different types. Because again, the great thing about scikit-learn is that it's a one-line command. Import decision tree. I really didn't appreciate this when I was learning it, but trust me, it's really nice. Import SVR. Import XGBoost. So, and Colab's got all these things built into it, so it becomes really easy. We're basically just doing the same thing we did. Now let me fix my test size to 0.2. Here, we can run it really quick. So I'm going to run it at 0.1, and then I'm going to run it at 0.5. So right now we're using 90% to train, 10% to predict. So the highest one we got was 50 XGBoost at 59, we'll say 60, okay? So but they're all looking really good. Now if I change this to 0.6, I'll just read it here real quick. Now we're at much higher, 60.8, 61%. Okay, so again, here's another method of how to actually do the homework. Say, hey, I'm going to take the linear regression that you made, and I'm going to try ridge regression. Well, right there, 54, that does it. So now maybe, is this one with the pretty, okay, so cross-fold. I did a grid search, I just wasn't sure if this is it. One second here, okay. So I believe in the last, so a grid search, sorry, this is a crossfold validation. 1, 2, 3, 4, 5, password. I'm just reading real quick. Okay, so let's explain crossfold or tenfold crossfold validation. Okay, so Cross. Pull up an image. Okay, so you want to say, hey, Richard, when I'm holding back data, I did a 50-50 split. So I use 50% of my data for training, 50% for prediction. Well, what's that saying? That means that the machine never really saw 50% of your data. Maybe there's some hidden intrinsic value in that data. I use 80% for training, 20% for testing. Again, maybe that 20% could be used for training. That's how we use k-fold validation, or let's see, or yeah, cross-validation. Right? It's not really the best map, but basically, let's look at this one. So this is literally what we're doing. I think we're doing a 5 or 10. Where, if we take 100% of our data, this would be using 80% of it for training, 20% for tests, 5 blocks, whatever. So then we do that one time, we get an error. Then we do it again, but now for the tests and training, we use a different chunk of data. We do it again here for a different chunk of data. That means we test literally every data point and we train on every data point. We just don't do it all at the same time. That makes sense. Oh, there we go, fold and training. Okay. That's kind of like this. So tenfold, cross-fold validation. Where is my R squared? My R squared 55. Again, you can change some of these variables. And this is just straight linear regression, but we're just cutting the data up in different sections. 54. So we went down. So there you go. But you're still above 36%. Now, maybe, and this is totally a fair question too, maybe you don't really want to do linear regression as business intelligence. I can understand. Maybe you're more Tableau and presentation. A lot of people in business intelligence shy away from the math, the graphs. They just want the data, and then once they have the data, they want to present it in a very artistic manner, very pretty manner. That is why I did this one. Because I want to be able to give you guys that freedom to do that too, because that's a very important skill that not all of us possess. So I want to make a pretty graph, okay? And so one thing I did, because as humans, we have a hard time understanding big numbers, 60,000 versus 60K. It's easier to understand 60K, 80K, 90K than 90,000. And I want to predict future values. I want to make a graph that shows me my prediction. Because what do you notice about this? These graphs right here, they only show the years we've inputted. The year 2000 to 2020. Well, and as a business decision, as a business leader, you got a good prediction line, but I'm not seeing that prediction, right? I mean, that makes sense. So let's make a graph that shows that prediction, that shows that future years and future predictions. Okay. And surprisingly, in almost all the classes I've ever taken, I've never made a graph with future predictions. And that just astounds me. I've come up, I mean, I've probably taken or learned linear regression at least 8 classes here at UNLV. And I've done linear regression predictions on pen and paper, but never made a graph with just something like this. And you can tell, I mean, again, this is just car and price. But the thing is, if you did salary, you did housing, you did something, the value of this is just immense. You take it to your boss and say, hey, you know what? If we want to spend no more than $40,000, we better buy a car by the year 2025. Or, hey, I know in the year 2030, we need to budget $50,000 for a car. I mean, this is a very simple, very clean graph. It's just, it's a prediction. It's not perfect. So some people may want to stick more on the technical side. Some people may want to stick on the more aesthetic side. Either way is fine. One of the challenges and one of the pros of business intelligence or data science is that there's no one right thing. If you think of a football player, maybe there's people that in the front that tackle each other, and then there's a quarterback that throws it, the person that catches it. So when you say football player, it can mean a lot of different things. business intelligence and data science is the same. You know, there's some people that want to deal with, you know, hey, I've evaluated, I mean, if you go up here, you tell your boss, and well, in looking at this data, I've used 1, 2, 3, 4, 5. Well, I've used 10 different regression models to calculate out the best method. And there's even something called a grid search, and there's a bunch of stuff you do. And I've come up with a model that shows R squared, a predictive ability of 60%. So basically, I can say I can account for what's it, price of the year with 60% accuracy, or 60% of my data accounts for that. Okay. So, I mean, that's a very technical thing. Or, and that's great. I mean, there's some people I know that are very smart. That's all they do is literally data. Hardcore data. And there's other people that make graphs like this that say, hey, you know, if you give me a different model, I can run a different model in here by just simply changing this line right in here. I could change it to XGBoost. I could change it to SVM. I could change it to anything. But this is what I have right here. So yeah, it's only 54%, but it gives you a good ballpark. I mean, if you were trying to budget for the next couple of years and you owned a business and you the cars right now are maybe 30,000, but in 5 years it'd be 40,000, you could adjust your budget. I just noticed these cats have little Halloween things on. So this, if you make something like this, you can just change it, do whatever you want, maybe different colors. You know, you could use this different model selection. You could do a crossfold. You know, you have this notebook, copy and paste, you know, use chat, GPT, use Slack Overflow. And there's all different types of linear regressions besides Psychic, besides this. So please just kind of, you know, spend 15 minutes, do your homework, get a good score, submit it. Then spend maybe, you know, if it's me, an hour to 2 hours trying to play around with linear regression, getting a really good score, not necessarily a good score, but getting something that intrigues you. You know, why does polynomial regression tend to be better for time series data? You know, what's L1, L2 regressions? You know, and you know, you can just add little notes to your notebook. You know, like I did up here. I think it was with this one. Maybe it was the other one. And yeah, I did it with the other one. But just add little notes, and then you know, submit that notebook to me too. All I'm asking you to do is just beat my very first run was it was like 36. So I mean, just going into this project blind, I hit 36%. So as long as you get better than an R squared of about 36, 37, you get an A in this assignment. So again, just play around with linear regression. It's just simple. You got two variables. You could add multiple variables. You know, I'm not going to show you necessarily how to do that in here to do a multiple regression, but it's not rocket scientist. There's a lot of tutorials. What's it? Chat GPT. Can you help me write? What do you call it? Write code for multiple regression in Python using sklearn with a car data set. So here's how you do a multiple regression. Again, you'd have to play around a little bit more, but yeah, this one's looking at mirror, mileage, and engine size, which all makes sense to me. So I know that, you know, I want to make sure my engine size is not null, my mileage is within normal reason, and my years within normal reason. You know? So if you guys have questions, I'm here to help. Let me know. You have plenty of time to do this. And also, additionally, if you want me to redo that machine learning video because the sound was kind of staticky or something, let me know. I run a recurrent neural network on my voice, and my voice is very deep. And I think that's what messed it up. I have no real scientific knowledge of that, but it could be. But if you want me to redo that machine learning model, I'll be more than happy to do that. If you have any problems technical-wise with the sound, the quality of the video, please let me know. I'm here to help you.